this is some work called Ungap the Map that I started a little bit before I joined the Turing with other people from the US listed here. So this morning in the keynote, Michael gave a great argument for why we need to prioritize cycling in cities, and so I won't talk about this. But what I will talk about is like why is there so much political resistance to it, and what can we do as researchers to kind of help the public understand the benefits. And these are sort of some of the common arguments that you'll see people make against cycling. And so I think part of the problem is how communication about the proposed networks looks. So these are examples of the government communicating to citizens what a proposed bike network looks like. It's just a picture. You can't even zoom into this and see street names. You definitely can't do something like Google Maps and say, you know, after this is built out, what would it look like for me to commute to work downtown using a bike versus now? You know, how much more comfortable and safe would it be? How many hills would I have to go through? You just sort of have this image and you have to interpret it yourself. And sometimes they also give a lot more detail. So you can look up these same plans on ArcGIS and like click on individual segments and see a bunch of information that's completely meaningless to you as a member of the public. Then the other way around, there are like cycling campaign groups, and whenever they like ask people for feedback about where they want cycle networks, the sort of state of the art for communicating that is just like a layer on top of Google Maps. Again, without the ability to route or show kind of before after benefit. But then there's examples of much more effective public engagement. This is a tool called Street Mix, where you can take a single slice of a street and kind of rearrange how space is allocated. And this thing is massively used by the general public and by government agencies to communicate back and forth because it's so easy and intuitive to use. And so Ungap the Map tries to effectively like blend these approaches and make a bike planning tool that's easy enough to use by anybody and communicates trade-offs more clearly. So this is what the tool looks like in Seattle. The first view just kind of shows you the existing cycle network, and you can turn on elevation layers so that you can see existing like protected cycle lanes or just paint along roads, like where is it in relation to where big hills are. So then the second thing you can do is make it route. So imagine we're going from downtown Seattle down to Columbia City. The route or the tool will show you two different routes. One is the fastest and the most direct, but usually it's the case that it passes through a lot of high stress roads. And so it's kind of going back and forth, but like right now, the second one with the up and down elevation profile was the longer, more indirect route. It's and this is usually the trade-off. Like if you're willing to cycle alongside like fast moving vehicle traffic, you can usually get there faster and experience less elevation gain, but you're taking risk, or you can go the slower hilly way. And this is not a trade-off that we want people to make. We want the easiest thing to be the safest. And so then the third function of the tool, you can just highlight a big chunk of road and say, right now there's no cycle infrastructure here, but based on my personal experience, I think there should be. And you can specify exactly what kind of infrastructure you want. You can say, I'm okay with just painted lanes. In this case, I think we've chosen to have striping and like bollards kind of separating the cycle lane from general traffic. And based on OpenStreetMap data, you can zoom into an individual road and also edit in detail if you don't like the lane configuration that the tool sort of generates. And then the last piece is sort of giving evidence on how much this could be used. And so the highlighted in blue is the new cycle lanes added to this map, and the sort of sequence of filters is showing how many people might convert existing driving trips to cycling. So a little bit about how this works. It's based on a tool called propensity to cycle. And so you have an existing demand model that describes where people try to travel today. And so the idea is you look for driving trips under like 5 or 10 kilometers that don't experience a lot of elevation gain. So if we had infrastructure as good as the Netherlands, then like those people are the ones that would be likely to cut over to cycling. So then you take those routes and say, do they intersect the new roads that you sort of drew in the tool? And then if so, there's an argument that those people could be convinced to switch over. And from this, you can sort of estimate a total mode shift. So the examples of this tool were all in Seattle. And that's because this works a little bit less well in the UK. One reason is that the tool that lets you select existing roads and then like add cycle lanes. It's based on the inferred width of the road based on OpenStreetMap data. And around the UK, there tend to be, or like the way lanes are tagged is different or not as good. And then also in places like London, you have really complicated infrastructure like the Elephant and Castle Junction, where you have cycle lanes or separated cycle tracks kind of alongside the main road. And the main road sort of splits and rejoins in a bunch of complicated ways. And it's a lot harder to just look at a road and say, is there room to add cycle lanes here? You know, how many vehicle lanes, how much parking do we could we take out? And so it's sort of ongoing work to improve these things, but until that happens, this tool has a little bit limited use here. And then I guess another point is the tool is very emphasizes cycling on main roads where you tend to have a lot of shops, but it's very valid, especially in the UK, to sort of form cycle networks as combinations of low traffic neighborhoods and main roads. And so, like, if you have an area bounded on all sides by main roads, and you can effectively filter a lot of vehicle traffic from cutting through, then you more or less have a cycle network. Like you'll still have some cars going there, but only if they're making deliveries or if they live there. And so those streets are quiet and nice to bike along. And as long as you can connect the two adjacent neighborhoods with good crossings and have reasonable infrastructure on the main roads, then you kind of have a cycle network for free. And so that tool, or the tool that on the previous slides doesn't really do that, but some more recent work on low traffic neighborhoods kind of shows you the estimation of how nice it is to cycle on local roads. And so like the future will kind of combine these two approaches and give you like a consolidated way of looking at cycle networks. And all this work is part of a larger platform called AV Street. It also includes some stuff to look at 15 or 20-minute cities. And most of the project is kind of focused on transforming very messy OpenStreetMap data into street networks that can kind of support this stuff. And yeah, it's all open source. You can run it in your web browser or natively. And yeah, if you want to try it out, it's preloaded in a bunch of places, or we can add one if it's missing. Thank you.